You have no chance against this problem if you don't have one math quality that is typically for smart people. This quality is so valuable that many big companies like Apple and Google chasing talented persons with that skill. I'm talking about creativity. So let's imagine a creativity way of solving this interesting problem. Here it is: equilateral triangle with entering point inside of him O. We have to find a length of a side of this triangle. At first, let's admit that we can see three inner triangles inside ABC. Here are them: AOB, BOC and AOC, or three sectors. Let's take a look at triangle BOC. And let's imagine a really creative thing, that we can rotate triangle BOC around point C. B is a free point, and we can use it to rotate triangle to left or to the right side around this point. So, if it's possible, let's take free point B and rotate this triangle until side BC becomes matching to side AC. In this case, point O becomes point O1, BO becomes AO1 with the same length 4, and OC becomes O1C with the same length 3. And now let's make a very interesting trick. Let's connect O and O1 and take a look at right triangle O1 OC. As we know that ACO1 equals to BCO, this and this, and BCA equals to 60 degrees because this triangle is equilateral. So we get that OC01 also equals to 60 degrees. Now in this triangle, let's admit that OC equals to O1C. So angles O1C and CO1O are also equals. And while OCO1 equals to 16 degrees, these two angles are also equals to 60 degrees. And OCO1 is an equilateral triangle, and OO1 equals to 3. Okay, and now look not at right but at the left triangle AO1O. What can you see there? Look at the lengths of his sides 3, 4 and 5. We can admit that 3 to the power of 2 plus 4 to the power of 2 equals to 5 to the power of 2. It's Pythagorean theorem, and it works only in one way, when AO1O equals to 90 degrees. Finally, what can we say? In triangle AO1C, angle AO1C equals to 150 degrees. And if we know the length of AC, the problem is solved, because AC equals to AB equals to BC. And how can we find AC knowing 4, 3 and angle 150? Very easy. Let's remember law of cosines. It says that in triangle AO1C, AC to the power of 2 equals to AO to the power of 2 plus O1C to the power of 2 minus 2 times AO1 times O1C times cosine from angle AO1C. AO1 equals to 4 and AO1 squared equals to 16. O1C equals to 3 while O1C squared equals to 9. AO1 times OIC equals to 4 times 3 equals to 12. And cosine of angle 150 degrees equals to minus cosine 30 degrees. And it equals to square root of 3 divided by 2. And there we get that AC squared equals to 25 plus 12 times square root of 3. And of course, AC, the length of equilateral triangle, equals to square root 25 plus 12 times square root of 3. Very creative, very smooth and very original way to solve this interesting geometrical problem.